Welcome to The Explainer. Today, we're going to talk about something huge, the colossal engine that drives our entire planet's climate. Think about it, a system that's constantly moving massive amounts of heat from the super hot equator all the way to the icy poles.
So, let's kick things off with a big question, right? The Earth is getting blasted with solar energy all the time, but most of it lands right in the middle, around the equator. So how in the world does all that heat make the journey from the planet's warm belly to its frozen over ends?
So to get our heads around this, we're going to break it down into 5 key parts. We'll start with the big picture. What exactly is this energy engine?
Okay, first up, let's really dig into what makes this engine tick.
So the basic idea here is actually pretty simple. The sun is the fuel for this whole thing, but it doesn't spread the heat around evenly. It's kind of like a giant space heater pointed right at the Earth's middle, leaving the top and bottom feeling pretty chilly.
And that's where latitude comes into play. You see, since the Earth is a sphere, the sun's rays hit the equator pretty much straight on, which concentrates all that heat. But way up at the poles, that same amount of energy gets spread out over a much larger area, so it's just not as intense.
What you end up with is this huge energy imbalance. You've got a massive surplus of heat at the equator and a big deficit at the poles. So the entire global climate system? Well, you can think of it as nature's grand attempt to balance that energy budget.
And this global engine, constantly churning and moving all this energy around, that is exactly what creates a place's climate over the long haul. It's the reason why, say, London has a pretty mild climate, but parts of Canada at the same latitude are frozen solid for a good chunk of the year.
All right, let's move on to the first major piece of this machine. We're going to see how water acts like a critical gear in this whole planetary engine.
Now, we all remember the water cycle from school, right? But I want you to rethink it for a second. It's not just about water going up and coming down. It's actually a massive energy delivery service. Every single drop of water is like a tiny rechargeable battery, carrying heat from one spot on the globe to another.
It all kicks off with evaporation. The sun beats down on the ocean, and that liquid water turns into vapor. This process is literally loading solar energy into the water molecules. They're like little energy packets, and they start rising up into the atmosphere.
Okay, this next part, condensation. This is the payoff. As that water vapor gets higher and cooler, it turns back into liquid droplets, and that's what forms clouds. And when it does that, bam, it releases all that stored energy as heat, and the amazing thing is, this can happen thousands of miles from where the water evaporated in the first place. It's like teleporting warmth across the planet.
And then, of course, you have precipitation. The water falls back to Earth as rain or snow. And just like that, the cycle is complete. A little packet of solar energy picked up in the tropics has just been successfully delivered to a much cooler part of the world.
Okay, so that's the atmosphere. Now let's look at the other major player in this engine, the massive globe-spanning ocean currents.
Seriously, try to picture this: enormous rivers flowing inside the oceans. These currents are constantly moving along predictable paths, and they are moving just staggering amounts of water, and of course, an immense amount of heat right along with it.
This is why we call them giant conveyor belts. You've got warm water from the equator traveling up toward the poles, dropping off its heat as it goes. At the same time, cold, really dense water from the poles sinks down to the ocean floor and flows back toward the equator. It creates this incredible, continuous loop that circulates around the entire globe.
So, there you have it, our 2 giant gears, the water cycle in the atmosphere and the ocean currents below. Now, let's see how they actually connect and work together to keep the planet's temperature in check.
The whole thing runs on one super simple rule of physics. Energy always moves from hot to cold. That's it. Heat is constantly trying to spread itself out, always looking for balance.
So here's how that plays out in the real world. You take a warm ocean current, like the Gulf Stream. It flows past Europe and releases heat into the cooler air, which is why their winters are milder. And it works the other way too. A cool current flowing along a coast can suck heat out of the air, which is why you might get fog and cooler summers. It's a constant two-way street, this energy exchange.
Okay, for our last section, let's zoom back out for a second and talk about just how delicate this whole global engine really is. So, you might be wondering, what's actually steering these massive ocean currents? Well, it turns out a huge driver is the wind. And I'm not talking about your everyday local breeze.
We're talking about the huge, consistent wind patterns that circle the entire planet, what we call prevailing winds.
So it's really a combination of two things. You've got this constant push from the wind, and then you have the continents acting like giant walls that force the water to turn. Those two factors together are what guide the ocean currents along their specific paths. They're basically the steering system that decides where all that warm and cold water goes.
So, what does that mean? It means that if those big, consistent wind patterns start to shift even just a little bit,
the entire heat delivery network for the planet can get rerouted. The steering wheel turns, basically, and the ocean currents get pushed onto totally new paths. And that could radically change where heat gets delivered, maybe causing some places to warm up like crazy, while others actually get colder.
And that leaves us with a really crucial thought. This whole planetary engine is so incredibly complex and interconnected. A tiny change in just one part, like the winds, can send ripples through the entire machine. So if the very systems that give us the stable weather we all depend on start to change, what happens then?